Good morning, Shubhamunjane. So, 3 sessions, properties of charges and the Coulombic force are discussed. Do remember, Coulombic force is discussed in many details for about 1 to 1.5 hours. Therefore, now, today's session will do some simple examples. When I said examples, as usual, please be ready with your books and pens, but not calculators. Keep all your calculators aside. Do simple calculation on your own. The properties of the charges and the Coulombic force. See some examples. The first example, the simplest example, in fact all are simplest only. Nothing to do with any huge words. The first one says, how does a copper sphere acquires a charge of 3 nanocoulomb? In what method we can make that sphere to acquire this excess charge plus 3 nanocoulomb is the question. Now I have told you earlier that charge on a conductor always speaks excess charge but not the total charge, total positive charge or total negative charge. No, it is the excess positive or excess negative. Now we know that by the modern electronic theory, conductor acquires excess charge by loss or gain of electrons such that here is going to be positive charge, and our discussion, you remember, loss of electrons give excess of positive charge. And now the same concept of quantization, loss or gain of electrons, acquiring excess charge. Therefore, our solution is this quantization. Q is equal to N times E. Since this is positive charge, N should be the case of loss of electrons. Remember? Finally, after getting the number, important thing is to mention whether it is the loss of electrons or gain of electrons. The data, excess positive charge, therefore this N is loss of electrons. Just substitution of numbers. Now I want Q is given to be 3 nanocoulomb and we know the value of E. We want the value of N. Therefore N is 1 by E times Q. And I have told you to remember that 1 by E value also earlier, which we can substitute directly. This is 6.25 times 10 rise 18 is what is number of, so 1 by E value. And this Q is now given to be 3 nano. Nano means the submultiple 10 rise minus 9. So this is, and in fact when you substitute here, generally students do oversight or maybe recklessness or maybe ignorance. This submultiple they forget, and I am again telling you, whenever you are doing any magnitudes, careful about multiples and submultiples. So 3 into 10 raised minus 8, yes, 6 3s 18, 25 3s 80, 75. Therefore the number you will get as 18.75, and this number 18 and minus 9, yes, it is 10 raised 9. So the answer is that the sphere should lose as many as 18.75 into 10 raised 9, those many number of electrons to acquire this excess charge in the given data. Just a kind of 1 mark, 2 mark questions. Now, see one more time, again the case of Q is equal to plus or minus Nu only I will use, but with one more step, extra step. And also that example, we will find one important, we can have some inference from the result also. Now what is that example? See, that example says that, supposing 10 raised 8 electrons are removed from a silver sphere per second, that is that, right? How many electrons? 10 raised 8 electrons per second are removed from a sphere continuously. Then find the time in which sphere acquires a charge of 1 coulomb is the question. Again you see, removed means it is loss of electrons and therefore it acquires positive charge. So again we have to make use of the same. What is that? Q is equal to N times E. Of course here it is positive sign because of the loss of electrons. Now Q is now given to be 1 Coulomb with no submultiple here, you see, no submultiple. I am telling you, when there is data to be converted into small expressions, the formulae in which a concept is known to us, that is what is the smartness of the student. That is where we have to improve our quality, converting data into symbols. Q is 1 Coulomb, use all SI units. Now we know this value of E, of course, as 1.6 into 10 raised minus 19. Now what about this N? This is what is the key. Earlier we have found the value of N and we got some number. But here N is not 10 power 8. Why? Because it is said that 10 raised 8 electrons are removed per second. That is only in 1 second. Now we need the time in which it is acquiring a charge of 1 Coulomb. Therefore now we need T. Therefore this 10 power 8 is only per second. Supposing we take it as T seconds. If T seconds we are taken, then this is 10 power 8 per second into T, the time taken to acquire this charge. Then this small n value is 10 power 8 times T is the important substitution. Okay. Once I do the substitution, it appears simpler for the students. But generally I am telling you, when you read the question, data to be converted into symbols is the most important element that the student has to acquire. 10 raised 8 T. Therefore now I want this T. So T value 1 by 1.6 into 10 raised minus 19 times 10 raised minus 8. The other way it goes. And already I have told you what is this value of 1 by E value. This 1 by E value 6.25 into 10 raised 18, and this is 10 raised minus 8. So the final number is 6.25 into 10 raised 10. These many, please remember, the entire SI units we have used. Therefore answer is 6.25 into 10 raised 10 seconds. Of course we have given the number. Now the question comes. What is this measure? 6.25 into 10 raised 10 seconds. How big unit it is, or if you convert that into hours or days or weeks or years, what is that we get? We know that one day 86,400 seconds. Remember, one day means, yes, 24 hours into 60 into 60. That number is 86,400 seconds. Per year means into 365. So that 86,400 into 365 will give you, I am just writing up to 2 decimals only. It is 3.15 into 10 raised 7 seconds. Do the calculation. One day means 86,400 seconds. Therefore, 1 year means 3.15 into 10 raised 7 seconds. Remember, this is the seconds which you have written equivalent to 1 year. Now look at this number. You have 10 raised 10. So how do we know, or how do we estimate that the duration, that is 6.25 into 10 raised 10 by 3.15 into 10 raised 7. If you do that, you will get it into number of years. Its number of years, nearly, of course, you are getting nearly 2, of course, 2 into 10 raised 3. That is nearly 2,000 years. Can you estimate that number? Even at the rate of 10 raised 8 electrons removed per second, to acquire a charge of 1 Coulomb, believe me, the number is we are getting as 2,000 years. And that is why in the very beginning we have told the SI unit of charge is Coulomb, but this magnitude of Coulomb is very, very big and enormous number. In all the practical cases, we will be having only the submultiples like nano micro Coulomb or pico micro Coulomb, or at the max we have micro Coulombs. but not of the order of coulombs. Coulomb is so big. How big? Now we can have an estimate. 2000 years it takes for getting a charge of this 1 coulomb for at this rate. So again, the example is based on Q is equal to Ne. Here the most important thing is writing the value of N. N value is 10 power 8 into T I have taken. Why? Because it is per second and we want the time. Therefore, this is the total number. This is the total time that is taken. See, Q is equal to Ne. I did 1 or 2 such simple examples. Now, let us come to another property of the charges or the conductors that we talked about. Now here, the next example says A and B are two identical spheres with the charges plus 15 microcoulomb and minus 3 microcoulomb. Both are touched with each other. Both are touched with each other. Find the charges on each of them is the question. Now here two things are important. Whenever you are reading the question, the keywords are important. Identical means same size. Same size, then the example is very simpler one. We make use of our conservation of charge. But otherwise, if it is of different sizes, then it is altogether different. Not that it is difficult, but that concept will come early in the latest part of our discussion. Now, identical spheres, charges, touch with each other. Earlier we have told conservation of charge. Whenever two systems are interacting, coming into contact, then what happens? Redistribution of energy such that for the case of same size, we have told this identity. So Q1 and Q2 are the charges before touching. Then Q1 becomes Q1 dash. And Q2 becomes Q2 dash, and this is after touching. Q1 becomes Q1 dash, Q2 becomes Q2 dash after touching. Such that same size, equal charge both acquiring due to redistribution of the charge. Therefore now here in this case, Q1 dash equal to Q2 dash equal to Q1 plus Q2 by 2. Q1 plus Q2 by 2. I am giving this example for 2 to 3 important things. What are those important things? First one is, when we are writing Q1 plus Q2 by 2, Q1 is going to be plus 15, Q2 is going to be minus 3. Additive property of charge, to remind you, number 1. Additive property when we are using the magnitude along with the sign. Minus 3 is there, is it not? Therefore here what I do is that plus 15 minus 3 becomes plus 12 by 2, it becomes plus 6 microcoulomb each. So charge on A plus 6 microcoulomb, charge on B plus 6 microcoulomb. Okay, the answer is okay. Now the point is that one more important point that we take is, before touching it was both positive and negative. You see they are unlike. After touching it is only like charges that appear. Numbers are 6 and 6, but also you can see that it is only positive charge on both of them. Again one more reminder, it is happening when the charges, when the conductors are of identical size. Even otherwise, even in the case of different sizes also, after touching they will always have like charges. Before touching it can be either like or unlike, but after touching it is always like charges. Now, in this example we have substituted charge along with the sign. Along with the sign we have substituted. And that is why we will have a kind of misconception. Next time, whenever we do examples on force, there we get again Q1 plus Q2 or Q1 minus Q2. This kind of mistake may appear there. That is, whether they will have to use additive property or something else, there I will make a mention. That is why when you are doing additive property, then only along with sign we are using. But other cases, Whether it is the same or not, we'll see that in our next examples. Coulombic force, few examples. First example, read the question carefully, because sometimes reading the question and missing few things, what makes is mess up with the answer. Especially it happens in the case of the competitive examinations like CT or NEET exams. Look, it is asked to compare gravitational force and Coulombic force between two protons, a very generalized question that I have given. I have not asked you to evaluate gravitational force between two protons or Coulombic force. It is only comparison that is asked. Supposing even if it is asked, force between two protons separated by a distance of 5 cm, 10 cm, supposing that number is also given, but simply asked to compare the things, not to evaluate the things. Because comparison means we will give in one line answer. If we want to evaluate, we will do that simple calculation there. Now we know that both gravitational force and Coulombic force, they are inverse square forces. Gravitational force, mass dependent, always attractive force. Coulombic force is charge dependent, and it can be either attractive or repulsive depending upon the nature of the charges. Now here, two protons, gravitational force always attractive. Now I am writing the gravitational force Fg, I am writing G for gravitational force, is the famous expression G m1 m2. Mass of each proton m, therefore I write it as m squared by distance between them is r squared. Now supposing you want the number, what is the gravitational force, then you will substitute these numbers. Remember, I am now just only comparing. For your additional note, you can do this also. What is the mass of the proton? I will give you 1.6 into 10 raised minus 27. This one. G value, of course, is again a known thing, 6.6, at least one decimal. 6.6 into 10 raised minus 11 SI units. And R, you take it as some 5 cm or 10 cm and then evaluate. You do it. Now I only compare. Now what is the Coulombic force? I am writing it as C for Coulombic is this small k we have told. Remember 1 by 4 pi epsilon naught. The magnitude is 9 into 10 raised 9. Then it is Q1, Q2. What is that Q1, Q2 now comes to be? Q1, Q2. What is the charge of proton? Same as that of electron. E into E squared by distance between them is r squared. So for a given distance, we are comparing gravitational force and Coulombic force. For a given distance. Now, I need comparison, right? Therefore, I am writing it as Fg upon Fc. Only this comparison. Then this r square term cancel. Therefore, you have G value. G value earlier I have told you 6.6 into 10 raised minus 11 minus 11. Yeah, gravitational force by Coulombic force is r square is cancelled. G value 6.6, 10 raised minus 11, and as I told you, mass of the proton 1.6, at least one decimal, 10 raised minus 27. 1.6 square means 2.56, right? Times 10 raised minus 27 squared. Therefore, you will get it as minus 54. See, look at these numbers. Numbers may appear to be with more fractional, and multiple submultiples will be more. And there actually an average student, an ordinary student, definitely he leaves everything. I am telling you in the classroom also, number of times I have mentioned you, simplification is your job. I should only help you. And what about this k value? K value only we have given, right? 9 into 10 raised 9. What is E? Again, charge of the electron 1.6 into 10 raised minus 19, and it is squared. Therefore, again it is 2.56 into 10 raised minus 19 square means minus 38 orders you will get. See, this is what finally you are getting. 2.56 gets cancelled. 6.6 by 9 you will get some decimal points. Now take the order only because we need the comparison. Take the order only. What are the orders you will get? This is minus 27 in the denominator, minus 27 orders in the denominator, and the numerator, look at this number 55, 65, 10 rise minus 65 orders you have in the numerator, minus 65 and minus 27. Yes, how many orders you are getting? 27 you are getting, right? Therefore it is like 10 rise minus 38 orders you are getting. And do remember, of course, this 6.6 by 9 is there, that will come in terms of units. Therefore, even if you convert that into decimal into unit, this will be 10 rise minus 39 orders you will get. 10 rise minus 39 orders. Supposing the same example asked you in the 5 marks examination for board, then you have to substitute the values. G value substitute, M value substitute, and given R value substitute, show the values. But here I have simply done the work of comparison. Of course, as homework you have to do those numbers also. Now you will see that, now let us see one important result from these numbers. Coulombic force is nearly 10 rise 39 times gravitational force we are getting in the case of proton. Not every time. For a given pair of particles we did an example. Look at this number, 10 rise 39 orders bigger. Those many times, and that is why I said gravitational force is weakest force and Coulombic force is a strong force in nature. These numbers will now will give that meaning how strong it is over the Coulombic force. Now, this is one such example based on Coulombic force and gravitational force we have told. Now, look at this one more example. Next example, again I did the case with Coulombic force. Say two copper spheres when rubbed with each other, they exchange 100 electrons between them. They exchange such a number, 1000 electrons between them. Now the question is, find the force between them when they are placed at a distance of 10 centimeters from each other. Is the question. Now, charges, distance and force. Nothing is said about the medium, means we will consider the medium to be air. Unless and otherwise specified with another unit, we always say the medium to be air or vacuum, remember. So place at a distance of 10 centimeters. Now the question is, again Q is equal to plus or minus any quantization. When rubbed with each other, we have told conservation of charge, modern theory of electron, they exchange electrons between them. Such that if one loses, the other will gain. Okay, then in such case, what is the Q1? Q1 is equal to plus 1000 E, because loss of electrons will be positive, and Q is equal to Ne, the charge acquired. Therefore, this Q1 equal to plus 1000 E. If you want the number, straight away you can write E value 1.6 into 10 raised minus 19. Here 10 cube order is there. Therefore, it is 1.6 into 10 raised minus 16 Coulomb. Then what is Q2? Q2 is, yes, it is minus 1000 E. If this is what is positive charge, same magnitude but negative acquired by the other, minus 1.6 into 10 raised minus 16 Coulomb. And what is the distance between them is going to be 10 centimeter. Remember, everything we need to convert into SI units, that is 0.1 meter, 10 raised minus 1, shall I write? 10 raised minus 1 meter, and now what remains is substitution and a small multiplication division. F is equal to K Q1 Q2 by R square. Remember, charges, distance between them, F equal to K Q1 Q2 by R square. K value is, yes, 1 by 4 pi epsilon naught, 9 into 10 raised 9 times charge Q1 Q2 multiplied. So this becomes 1.6 square, it becomes 2.56 into 10 raised minus 32, because it is minus 16 squared upon 10 raised minus 1. This is all the number that you get. So the final numbers will be 2.56 into 9. Look at the orders. This is minus 1 becomes a 10 and this is minus 32. So first the order is a 10 rise, yes, minus 22 Newton you have, and look at the numbers. 9 2s 18, 9 5s 45. Therefore it is like 24.5, something like 24.7 something. This is what is your job. I again keep telling you. This 9 into 2.56 you have to do it for yourself. I am just writing a near value. Maybe or may not be right, you have to do it. 24.7 into 10 times minus 22 Newton. Right? K Q1 Q2 by R square substitution. Now the same example, ask in your CET or NEET with a small difference. What is the difference? Same question, asked in an improvised way for that 30 seconds or 1 minute answer. Right? If you got this answer, now you see. I tell A and B, two spheres. A and B, two spheres. They exchange, suppose, 100 electrons between them. 100 electrons between them, and the force between them for a given distance is F, or some number is given. F is the force between those two spheres which have exchanged 100 electrons between them. Okay. Now the question is that if A and B exchange 300 electrons instead of 100, if it is 300 electrons they exchange between them, for the same distance between them, for the same separation between them, what will be the new force is the question. What will be the new question? So this is how, same example asked in a different way. It appears a different example, no, the same example. What is that? Now here earlier we have seen with number. Now let us take Q1 is equal to plus Ne and Q2 is equal to minus Ne. Right? Q1 is plus Ne, number of electrons exchanged between them, positive and negative charge. We know that F proportional to Q1, Q2, is it not? For the same separation, no change in the distance, it is constant. F proportional to Q1, Q2. Then what does it mean? What does that you get? F proportional to, when you multiply both Q1 and Q2, here you are getting N square E square. Now here you see that this E is of course a universal constant. F proportional to N square is the take from this discussion. Whenever this exam is given, exchange of electrons between them, and for a given separation the force, then what is the result that we are using? If you have followed this, now see. If you have followed this, what is the case that we have to take? F proportional to N square. F proportional to N square. Therefore, now here I write F dash by F. F dash by F. What is the again meaning? F is the given, known, initial. F dash, the final, unknown, which is required. F dash by F. Since this is directly proportional, shall I say N dash by N. And this is index squared. And N dash is going to be 300 by 100. Right? It is completely 3 squared. Therefore, F dash is equal to, you get it as 9F. 300 by 100, 3 squared. Therefore, F dash is equal to 9F. F becomes 9F, becomes 9 times. Becomes 9 times means increased by 8 times. See, this is how in CET NEET examination the important term. F becomes 9F. Increases by 8F, or else F becomes 900%. Becomes 9 times means becomes 900%. Increased by 8 times means increases by 800%. These are important things for CET NEET examination where objectives with options are given. Finding the right English option is also a very important thing. F proportional to R. And one more thing, remember, when you did this plus and minus in the value of Q1 and Q2, finally you are getting F with negative value, because Q1, Q2 plus into minus, you will get minus. Now always this minus sign will have a significance. Significance. How? In this case, see example, we are getting negative value for the force because it is Q1, Q2 product is, we are getting negative. And what is the significance of negative sign? Negative sign here it means attractive between unlike charges. But negative mean does not always imply that it is attractive. Maybe sometimes or most of the times this negative sign having a significance of attractive nature. But sometimes we will also see those examples. There is not, it is not a meaning or significance of attractive force. It will have a different meaning also. And that is why whenever that negative sign comes in our result, I will explain the significance. You take care of that significance also. You like this F equal to K Q1 Q2 by R square. Next example, I said two charged spheres A and B exert a force of 0.2 Newton for a given separation between them. It is 0.2 Newton either attractive or repulsive depending upon the nature. Now the question is, charge on A increased by 30% and the charge of B decreased by 30%. Find new force between them for the same separation is the question. Generally here the student will immediately conclude that 30% increase in one and 30% decrease in the other. Therefore the force between them remains the same because the distance also not changing. So they may conclude that the force remains the same 0.2 Newton. But is it the answer? Let us see. Now as I have told you, Coulomb force, what are the different parameters you have? You have charges Q1, Q2. Second one is distance between them. Third one is medium in which the charges are placed. And the fourth one is force. There are four parameters. Which of them is changing, which of them are given, which of them are known, which of them are unknown. This is how we understand a question. You should begin always thinking like this. Not simply remembering formula, substitute, get your answers. No. Because all these things we require for next 2021, remember. So that is why it should be a very solid concept to us. 100% digestion should happen. Charges, distance, medium, force. So this is how four things are there. For now, let me tell you, maybe I will take 10 minutes of time for this simplification. Actually, it requires only 30 seconds. But let me explain it in detail so that any examples based on Coulomb force, this is your one of the tools. Now, whatever I am now telling you is not a formula. It is a tool to approach the Coulombic examples based on Coulombic force. Now you see, as I have told you, the charges are Q1 and Q2. Suppose this is the pair of charges Q1 and Q2 separated by a distance R in a given medium of constant K. It can be either 1 or greater than 1. We have told K for dielectric constant. Now in this case, the force is F between the two charges. Now what are the different possibilities of the changes that we can think of, which will be our examples in any type of examination. Now charges changing, either one or both. Any of them can be changed. Suppose Q1 changed to Q1 prime, changed. Q2 also changed Q2 prime. Now here I am writing the changes. Whichever has changed, only that will be substituted, other will remain as it is. Now supposing the distance can change, the distance changed to R prime, R becoming R prime. And suppose medium is changed and medium becomes K prime. Then the new force between them is, yes, I am writing as F dash F prime, such that we now know that F proportional to Q1 Q2, force and Q1 Q2 directly proportional, force and the square of the distance inversely proportional, force and dielectric constant is also inversely proportional. Remember F dash equal to F by K we have given, right? Therefore, now this is what is the tool I am giving. The new force F dash compared with the old force F or the given force F, then this will be force charges directly proportional. Therefore, it is Q1 prime, Q2 prime by Q1, Q2. Now, whichever is changing, that change we will substitute. Then this is distance. Distance we are told inverse square. Therefore, it is F dash by F. Here I will write it as R upon R dash. And there is inverse square, that is. And depending on the medium dielectric constant also, and that is inversely proportional. Therefore, I will write it as K upon K dash is the other one. Right. See, now what you observe is here you have 4 ratios this tool has. Changes in charge, changes in distance, changes in medium, the change of force. Now 4 ratios, any 3 ratios given, ask it for the 4th one. These are very popular for our all types of examination. People will find it as very difficult things because lack of memory, they say, they forget the formulae, they say, and whatnot. All these many things are to be avoided by making use of our tools. So this is the tool I am telling you. Now in this case, in the given example, you see how I make use of this expression. Here no change in distance. This ratio I will make it as 1. No change in the medium also, nothing is said about. Therefore I will take this ratio also 1. Right? Therefore, now if you take in this as a tool, I am using it for the given example. How? This K upon K dash ratio 1 or this ratio is also 1. Therefore this is what is our new equation. Now this is not a formula, again I am telling you. This is how we have observed the things, the changes and the relation. Now let us write now. First, suppose Q1 is equal to QA is equal to some Q1 and QB is equal to Q2. Number of times I have told you, just now also I have told you that whatever data is given, the data are to be converted into symbols. This is what is the student has to cultivate. Complete first year I have been telling the same, right? Not English part of physics. Beyond English we will learn physics. Please make use of these symbols, convert data into symbols. Now QA, QB, this is Q1 and Q2. Now what is said? It is said that the charges on A and B change such that, now what is that new QA dash, QA dash, or else I will write it as Q1 dash because Q1 has changed, right? Therefore now what is the Q1 dash, the new force, Q1 change. He said increased by 30%. 30% means 0.3, increase means 1 plus. Decrease means 1 minus. Remember, 1 year we did all such things regularly in the classroom. Q1 dash is 1.3 Q1 I am writing. Why 1.3? 30% increase. Now similarly Q2 is said to be decreased. Therefore Q2 dash I will write it as 30% means 0.3. Decrease it means 1 minus 0.3. It becomes 0.7 times Q2. 0.7 times Q2. Now let us just substitute the numbers and get the answer. Therefore now here F dash by F is, this is 1.3 times 0.7 Q1 Q2 and denominator you have Q1 Q2. Yes, cancellation. Now final answer is F dash is equal to 13/7 jar. Yes, 13/7 jar. Actually, I should not do all such numbers, it is your case. 13.6 into this is 81, is it not? So this is 0.81 times F you are getting. 0.81 F you are getting. Now please look at these numbers. If it is 0.81, what does it mean? F dash is less than F. Force has decreased. Number 1. How much it is decreased will be like CET NEET question. Here 0.81 means less than 1. By what amount? 0.19. Therefore, now again comes finding the right option. Now the options can be like the force between the charges becomes 81%, that is 0.2 into 81. That is what is the answer. You will get that, substitute the number. Or else the force between the spheres decreases by 19%. 30% increase, 30% decrease on the two spheres for the same separation and medium. Force is decreasing by 19%. Instead of numbers, if it is percentage change, people think that it is NEET and CET. No, it can be the question in any of the examinations, right? So Coulombic force, what is that important tool I have told you? Yes, new force compared with the given force. is Q1 dash Q2 dash by Q1 Q2. Yes, R upon R dash squared and K upon K dash. When you come back, when we do our regular theory classes and then our other competitive examination coachings, then you will find good number of examples, right? Here, I hope you will take this tool and use it for some of the examples. Two charges are given, only two charges, Q1 and Q2, said to be placed at the two corners A and B of a square ABCD side L. So it is only two charges placed at A and B. Now the question is, two charges placed at A and B, the force between them is 0.1 Newton. 0.1 Newton. Now the question is, if the charge at B is displaced to the corner C, so the charge which is Q2 at the corner B is shifted to the other corner C. What is the new force between them? Yes, it is the question. Or else, what will be the change in the force can also be a question. Now here, no changes in the charge, right? Same Q1 and Q2, but and no change in the medium also. So what is the only thing that has changed here? Yes, it is the distance between the two charges. When it shifted from B to C, the distance between the charges is increasing. That is the only thing that we have to take, and now using our tool. And of course, common sense, because the given geometry is a square, and we know what are the different dimensions with respect to squares. The length of diagonal, areas, what are different angles that we can come across in squares. All those geometry is an important common sense. Now here, if we are making use of that earlier tool we have given, then no change in the charge, therefore that Q1 dash Q2 dash by Q1 Q2, that ratio we take it as 1. No change in medium, K by K dash, that ratio is also taken to be 1, and therefore the new force when you write this is F dash upon F is R upon R dash. Don't forget you have this square because it is inverse square relation. Now simply writing that common sense. What is that? Initially A and B, therefore initially R is equal to L. Whereas what is R dash? L means AB, the side. Now what is R dash? R dash is nothing but AC, which is the diagonal. AB is the side and AC becomes diagonal, and for a square we know that it is root 2 times L. Root 2 times L. Therefore substitute here. What is that you get? L root 2L. L getting cancelled. What is that you get? 1 by root 2 squared. Therefore F dash is nothing but F by 2. So what is the new force between them? Is half of the initial force. Numbers are given, substitute and write the numbers. Especially in competitive examinations or even for that matter board examination, careful about the questioning, whether you are asked to find the changed value or change in the value. If it is changed value, the answer is F dash. If it is a change in the value, it is F dash, difference F. Then it can be either increasing or decreasing. So here force is halved is our answer. So that is how, when you look at these, this is what I keep telling you, keywords. Charges, distance, medium, force, what is the changes that are happening, how to substitute those changes. Very simple solutions. So instead of two charges, let us take up multiple charges. System of multiple charges, I am taking with number 3 and then 4, so on. Let us do that. Remember, here I will do one simple example, and after that some things have to be discussed once we get the answer. Other things have to be discussed, and that is where it takes more and more time. But generally the solution is only for 2 minutes. What is that? Here you will find the system of charges, 3-point charges plus 3 microcoulomb, this is minus 2 microcoulomb, 7 microcoulomb is said to be placed along the x-axis with positions. This is at x 20 centimeter, this is 40 centimeter, and this is 70 centimeter. Now the question is just open. Find the net force on the plus 3 microcoulomb or plus 7 microcoulomb or this middle charge, whatever it is. So finding the net force. I will do one such example here between net force on one particular charge. For the other two charges, you will do it as a small homework. Right. Now let us see. We are using the expression two charges. Though it is three charges, what we have to do? See, it is a step process. First, now I have identified, I want to find net force on minus 2 microcoulomb. I am doing it for. You can do it for the other examples also. Right? First I am doing for minus 2 microcoulomb. Then we have to look at the system, how many pairs are possible. Now this 2 microcoulomb force due to 3, positive 3 microcoulomb is there. This is also 7 microcoulomb is also there. Therefore it will experience two forces. First now let us write that basic F is equal to K Q1 Q2 by R square, which we will use 2 times because there are 2 pairs. 2 microcoulomb plus 3 microcoulomb, 1 pair. 2 microcoulomb and the 7 microcoulomb is also another pair. Of course, signs are there, whether like or unlike, observe carefully. Now using that, first for the pair plus 3 microcoulomb comma minus 2 microcoulomb, what is the force that I get? I write it as F1, K value 9 times, yes, 10 raised 9, Q1, Q2 multiply 3 and 2, it is 6 micro into micro, 10 raised minus 12. This is an important thing. Generally people do forget about that subparticle. See, 2 microcoulomb into 3 microcoulomb is not 6, it is 6 into 10 raised minus 12. Now what is the distance between them? This is at 20 centimeter position, 40 centimeter position, therefore the distance between them is 20 centimeter, the distance between them. Therefore now here I have written 20 centimeter, 0.2 meters. 0.2 meters, all SI units squared, therefore it will be 4 into 10 raised minus 2. R squared term you will get 0.2 squared, 4 into 10 raised minus 2. So this is total you will get as 53 by 2. 27 by 2. The magnitude. Now let us come to subparticles. 9 and minus 2 becomes plus 11. And this is minus 12, therefore this is 10 raised minus 1. 10 raised minus 1, of course you will do those calculations. 13.5, since there is 10 raised minus 1, it becomes 1.35. 1.35 will be Newton. And now the most important thing is, I have told you, whenever multiple charges are given, it is not just magnitude but also vector and direction, vector addition. Therefore now here you see this 3 microcoulomb, this is minus 2 microcoulomb, due to positive, that is unlike, it is always attractive. Therefore the direction F1 I am showing you, this is what is F1. This is what is F1, minus 1.3 Newton. This is towards plus 3 microcoulomb. Is it not? Now similarly let us calculate what is the force on the pair, minus 2 microcoulomb and plus 7 microcoulomb. Again same K Q1 Q2 by R square. If I call that force as F2, 9 times 10 raised 9, Q1 Q2 14 into 10 raised minus 12, of course, please don't forget. Now distance term, you see here, this is 40 centimeter position, 70 centimeter position. The distance between them is, yes, 30 centimeter. So these are the common sense things that the student has to observe and make correct substitution of numbers or symbols or units. 30 centimeter, therefore it is 0.3 meter, can I say, squared, 9 into 10 raised minus 2, 9 into 10 raised minus 2. So finally you get 9 cancelled, 14 times Again 10 raised minus 11 and plus 11 and minus 12. So this is 10 raised minus 1. Therefore this is 1.4 Newton. 1.4 Newton. See, when you have taken Q1 and Q2 plus 7 into minus 2, it will be minus 14. But that negative sign for the charge I should not use when system of multiple charges, finding net force by vector addition. Therefore, the negative sign given to the charge is not at all carried into the substitution. We have to take only the magnitudes. Whether it comes plus or minus, it is not due to additive property of the charge, it is due to vector addition. Remember? Therefore here, minus 2, you may somebody call, sir, this is minus 1.4 Newton. Don't take that minus 1.4 Newton, rather take the direction. Now it is towards plus 7 microcoulomb, because this is again attraction towards. Therefore, this is the another force F2 directed like this. This is what is F2 bar. This is F1 bar. So writing those vectors is the important thing. Now here no question of any scalar additions. That is why net force examples, additive property of charge, please never use. Okay. Now 1.4 Newton towards, what will be the net force? This is the situation that you have got here. Now let me show here. This is minus 2 microcoulomb with two forces. F2 towards your right hand side and F1 towards your left hand side, such that what you find, F2 1.4, F1 is 1.35 Newton. This one is a higher magnitude. Therefore now I am writing it as net force. On which charge I am taking? Minus 2 microcoulomb is 1.4 minus 1.35. 1.4 minus 1.35, no submultiples, everything is in Newton. Why this negative sign? Vectors. Anti-parallel minus, parallel plus, any other angle, root of p square plus q square plus 2pq cos theta. So this is our regular vector addition principle in our first PU. Therefore this answer is 0.05. Is it okay? 0.05 Newton is the answer, and also the direction. If it is B or C examples, this is what is the important thing. Up to that last statement we should be very careful. The answer is 0.05 Newton. Final answer is yes, towards plus 7 microcoulomb. It is towards plus 7 microcoulomb. Why? Because see here, plus 3 and plus 7. Which will have more attraction? Because this magnitude is same, it will have more attraction. F2 value is higher. So final answer is 0.05 Newton towards plus 7 microcoulomb. So this is how examples goes for system of multiple charges. At this stage, I just stop this session. Tomorrow's session will start with other things that we have to take from this example, because system of charges when it is the case, other things which are the derivatives from this question will follow that in our next session. Have a very great day. Good day.